Next work comes from University of Ljubljana. Mr. Uroš Stritih will present their work, Active PCM Thermal Storage System for Free Heating and Free Cooling Buildings. Mr. Stritih, the floor is yours.
Thank you. So, good day everybody. I'm coming from University of Ljubljana. I'm assistant professor for heating, ventilation, air conditioning, house technologies. And in this talk I will talk about energy storage for free heating and free cooling of building, which is very connected to the lecture we had before, but with the accumulation of energy. So PCM is the phase change materials which are used in some buildings, you will see. For the introduction, we know that a lot of energy is used for the building, about 40%, and we have European Building Directive which gives us path to reduce the energy for heating and cooling, and we have options to use renewable energy sources, and we have other options to use rational energy use. And in this case, we are using thermal energy storage with phase change materials. Phase change materials is material which change aggregate state from solid to liquid and vice versa, and with this it accumulates the energy. We call it latent heat storage, which is gaining a lot of importance in the world, as you will see. And we can use it as a storage integrate to the building envelope or in the HVAC system or standalone system. I will talk about the second one and the third one, so as an active system. We can see here two examples. So first, in the left side is the Hamburg, Germany building which is used for cooling, and on the right hand side we are using, you can see the picture of Botanic Garden in Berlin, which is used for heating. Some data here. So the first building in Hamburg, they are using 5 kilograms of PCM, melting point 22 degrees per square area, so they get about 60 watt per square meter of cooling. In the summertime, when the temperature drops below 18 degrees, the system is filled in the night and is used for the cooling below 26 degrees during the day. The second building in Berlin, it's used PCM modules for plants, and they are filled during the day. So those are two examples. Our idea was to combine those two, and we are using the cold summer nights to fill the storage with cool energy and use it during the day. And in the winter times we are using solar air collector to store the heat in the same material and to heating the air in the night, morning and in the evening time. So here's our example. You can see the outdoor space on the left side where the sun and the inside is on the right side. This is a storage. You can see the panels of phase change material. Those are plates you will see after that. And the operation in the summertime, during the night, you can see the air which is coming through. So the cold air is blowing through, and the PCM, the material is solidified. And during the daytime, when we use the outside air for the ventilation of the house, this hot air during summer is cooled down. In the winter time, we are using solar air collector, so the cold air is heated, and this heat, the hot air, is going through those, let's say, they call it panels or plates, and the material is melted, and during the evening or the morning hours, the cold air is coming through and is heated up. This is the principle. We have made an experimental setup, and we are using or calculating the energy for office, and we are using Rubitherm plates with the melting point of 22 degrees because we want to use it for heating and cooling. So you can see the picture of the storage here on the left side. So this is the storage where the plates are inserted, about 30 of them. You can see this is the inlet duct, and this is the coming out, and this is coming to the room. Here you can see the solar air collector mounted on the facade. This is on the Faculty of Mechanical Engineering. So this is the storage, insulated with 5 centimeter insulation. Those are dimensions, and this is we call it macro encapsulated phase change material. The plates are 30 centimeters, 40 centimeters, and 1.5 centimeters thick. And we used 29 plates because one have been put apart to see how it's made of. So this is one plate. It looks like this, about 1 kilogram, and those the other dimensions here. So it's German company Rubitherm, and those are some data about insulation, about the fan which is used for the blowing of the air, and the solar air collector is a Slovenian product. So cooling mode, as we have said, during the night time the cold air is supplied to the storage and the PCM solidifies, and during the day the warm air is cooled down. The heating, so we have a solar, if we have a solar radiation, the hot air is coming through the storage and PCM melts, and when we don't have radiation or during the evening and morning hours, so we heat the air for the building. So this is the experiment which we have made with different measuring points with the thermocouples, and we also have measured electrical power for the fan and the speed of air, and temperature sensors have been used because we have also modeled this with trances. So you can see here cooling mode. So this is the air during the summertime. The inlet air, it comes also to 30 degrees, and this is the outlet air of the storage. So we can see that without additional energy, we cool down the air to about 20-21 degrees. The idea or the point is that the air is very close the temperature to the melting point. Is one day you can see the oscillation of the temperature, inlet air, and this is the outlet air which is coming through the storage to the office. Heating mode, you can see the red line is the temperature out of the collector. The blue line is the temperature of the surrounding. Is in the winter a little more than 0, and this red line is the temperature of the air which is coming out of the storage. Again, a little around to melting point. This is 2-day cycle. You can see 2 days of the hot air. This is the outside temperature, and this is the temperature of the air which is coming through the storage to the building. Some conclusions. So this phase change method technology is an alternative to conventional systems, so to use the free energy, cold and heat, to reduce the energy use for buildings, but it's used for daily cycles. And what we also have seen that delivers air at very constant temperature. Thank you for your attention. If there are questions, yes, please.
I have two questions. First one is, what specific phase change materials you are using in your system? Is it Glauber salt or some other one? And the second question is, what is the life cycle of that material? I suppose it is not unlimited.
Okay, so it's paraffin. It's not a salt. It's the paraffin with melting peak 22 degrees, but it has some temperature when it starts to melt and freeze. And there's also hysteresis, but this is what the DSC comes out. And the next question is very important. So the cycles, you are asking about this, yes. We can get those information from the manufacturer, I think from the Rubiter. If you want, you can see on the web page, it's rubiter.de. But yeah, I think for the paraffins there is not so much problems with the cycles, but with the salts there are more problems. Because it's not very reversible, because the salt comes to the down and there are some subcooling problems and other problems which has to be solved. This is what I know. If there is some other question.